Most printing problems are not printing problems. They are design problems that the printer was asked to solve and could not. A 3D printer builds by stacking layers upward, and that one fact drives every rule in this video. Design with it and parts come out clean. Design against it and you spend your evening fighting supports. 6 things to get right: overhangs, holes, tolerances, orientation, strength, and knowing when to split a part in two. Chapter 1: Overhangs and the 45-degree rule. Each layer sits on the one below it. If a layer only overlaps the previous one by a little, it has almost nothing to hold onto and it droops. At 45 degrees, each layer still overlaps the one below by about half its width. That is enough. Anything shallower than 45 degrees prints cleanly with no support at all. So the first design move is simple: replace flat ledges with chamfers. A shelf sticking straight out needs support. The same shelf with a 45-degree underside does not. The same applies to the bottom of a part. If it flares outward from the plate, chamfer it instead, and the whole thing prints supported by itself. And bridges are the exception worth knowing. A flat roof between two walls will print fine if it is short, because the plastic is stretched between two anchor points rather than hanging off one. Chapter 2: Holes. Holes are the single most common thing people get wrong, and there are 2 separate problems with them. The first is orientation. A hole in a vertical wall has a flat roof, and a flat roof is a 90-degree overhang. It sags every time. Make the top of the hole a point instead, so it becomes a teardrop and it prints perfectly. If you cannot use a teardrop because the hole has to stay round, a hexagonal top works nearly as well, and it looks deliberate rather than odd. The second problem is size. As the nozzle goes around the inside of a hole, it drags material inward, so holes come out consistently undersized, usually by around 1/10 to 2/10 of a millimeter. So design holes slightly larger than the bolt, or use XY hole compensation in the slicer. And if a hole absolutely has to be accurate, model it undersized and drill it afterwards. Chapter 3: Tolerance and fit. 2 parts that measure correctly in CAD will not fit together when printed, because melted plastic spreads slightly wider than the path the nozzle took. So you design the gap in. For something that needs to slide, leave about 2/10 of a millimeter. For a press fit that should stay put, about 1/10. For a part that has to snap together and come apart repeatedly, go wider, around 3/10, and let the geometry do the holding rather than friction. Print a tolerance test once. One small part with a row of different gaps tells you exactly what your printer needs, and then you never guess again. And calibrate your flow before you trust any of these numbers. If you are over-extruding, every part comes out fat, and no amount of clearance will save you. Chapter 4: Orientation. Orientation is the most powerful decision you make, and it costs nothing. It changes strength, surface finish, support requirement, and print time all at once. Layers are glued together, and that glue is the weak direction. So work out which way the part gets loaded, and lay the layers across that force rather than along it. A hook printed lying flat is many times stronger than the identical hook printed standing up. Same file, same filament, same settings. Orientation also decides your surfaces. The face on the build plate comes out flat and even. The top comes out smooth. The sides show layer lines. Point your best surface at whichever of those you want. And rotating a part 45 degrees will often remove every support it needed. Always try a few angles in the preview before you accept supports as inevitable. Chapter 5: Designing for strength. Strength in a printed part comes from walls, not infill. 3 walls at 15% infill beats 2 walls at 50% and prints far faster. So design with wall thickness in mind. Make load-bearing sections a clean multiple of your line width, usually 0.4 millimeters, so the slicer fills them with solid walls instead of a thin gap it cannot fill. Avoid sharp internal corners. They concentrate stress, and a printed part will crack there first. A small fillet costs nothing and makes a genuine difference. Add ribs rather than thickness. A thin wall with a few ribs behind it is stiffer, lighter, and faster to print than the same wall made twice as thick. And when you need a real screw thread, design in a pocket for a heat set insert rather than screwing into plastic. Plastic threads strip, brass ones do not. Chapter 6. When to split. Sometimes the right answer is to stop being clever and cut the part in half. Split it when it is bigger than your plate, obviously, but also split it when one orientation would need supports on a surface you care about, or when different parts of it want different orientations for strength. Cut on a flat face or a natural edge so the seam lands somewhere it will not be noticed, never straight through the middle of a curve. Add alignment pins and give them about 0.2 of a millimeter of clearance, exactly like any other fit. Most slicers will add the pins and holes for you. Glue with 2-part epoxy for anything structural. It fills the joint as well as bonding it, which superglue does not. So chamfer your overhangs, teardrop your holes, design the gap in, orient before you model, put strength in walls, and split when splitting is simpler. None of these cost print time. Most of them save it because the part needs fewer supports and less cleanup. And the biggest one is free. Decide which way up the part prints before you draw it, not after. Design it right, and the printer stops being the thing that limits what you can make. If this helped, subscribe to Layer Logic. There is a short video on most of these rules if you want to go deeper on any one.